Good morning everyone. It's me Arjun Pokhrel, science teacher of Sagarmatha Secondary School. Welcome to you all in my online class. Today we are going to discuss about the topic variation of acceleration due to gravity. Today we are going to discuss about the topic variation of acceleration due to gravity with height. Acceleration due to gravity G at a height h from the surface of the earth is given by the formula G prime is equal to capital G capital M by R plus H whole square. We know that acceleration due to gravity G is equal to Gm by only R square, but acceleration due to gravity at a height h from the surface of the earth is given by the formula G prime is equal to Gm by R plus H whole square, where M is the mass of the earth, capital M is the what? Mass of earth, and R is its radius. The value of acceleration due to gravity decreases with the increase in height from the earth. Okay, the value of acceleration due to what? Gravity decreases with the increase in height from the earth's surface, because acceleration due to gravity is inversely proportional to the square of the radius of the earth. Suppose this is earth. Okay, suppose this is earth, and this is what? This is the center of the earth, and this is the radius of the earth. Radius of the earth is represented as what? R, and mass of this earth is what? M. Okay, mass of the earth is capital M. Okay, if a substance is present above the surface of the earth, this is the surface of the earth. Okay, if the substance is present above the surface of the earth in the certain height, suppose if the substance is present here, okay, then the distance between the surface of the earth and the substance is considered as h. Okay, the distance between the substance from the surface of the earth is considered as h. Total distance from the center of the earth to the substance is considered as what? R plus h. Total distance what? R plus h. Total distance R plus h. Okay, and at that condition, G prime acceleration due to gravity G prime. Okay, at the surface of the earth, acceleration due to gravity is denoted by only G. Okay, but at the at certain height, yes, from the surface of the earth, then after we have to use the term G prime instead of G. At that condition, G prime is equal to Gm by R plus H whole square. R plus H whole square. Okay, M is what? Capital M, it means mass of the earth. R means radius of earth. H means height. Okay, or the distance between the substance, okay, from the surface of the earth. At that time, acceleration due to gravity G prime is equal to Gm by R plus H whole square. Write down one question. The value of acceleration due to gravity is less at the top of Mount Everest than that in the Tarai region. Okay, suppose this is Mount Everest. Suppose this is what? Mount Everest. The value of acceleration due to gravity is less. Acceleration due to gravity is less at the top, okay, of Mount Everest than that in the Tarai region, than that in the surface of the earth, or considered as what? Tarai region of Nepal. Why? Okay, we know that the acceleration due to gravity at a height from the surface of the earth is given by G prime is equal to Gm by R plus H whole square. It means when height from the sea level increases, okay, the acceleration due to gravity decreases. Okay, when height from the sea level increases, then acceleration due to gravity what? Decreases. The height at Mount Everest is more than the Tarai region in our country. Okay, the height at Mount Everest is what? More than the Tarai region. So the value of acceleration due to gravity is less at the top of Mount Everest in comparison to Tarai region of Nepal. On memory tips, the value of acceleration due to gravity is maximum at the Earth's surface and decreases with height and depth. It becomes zero at the center of the Earth. And this is the center of the Earth. Okay, and this is what? Radius of the Earth. Suppose the radius of the Earth. The value of acceleration due to gravity is maximum at the surface, this surface. Okay, as we go down from the surface of the Earth, okay, acceleration due to gravity was decreases. And if we go up from the surface of the Earth, acceleration due to gravity decreases. Okay, in both conditions, acceleration due to gravity is maximum at the surface of the Earth. Here, acceleration due to gravity is maximum at the surface of the Earth. If you go down from the surface of the Earth, acceleration due to gravity decreases. And if you go up from the surface of the Earth, acceleration due to gravity decreases. If you go down from the surface of the Earth, acceleration due to gravity decreases. And center, at the center of the Earth, acceleration due to gravity. At the center of the Earth, acceleration due to gravity becomes zero because there is no radius, and the acceleration due to gravity is maximum at the surface of the Earth. This surface, acceleration due to gravity is maximum, and if you go up, acceleration due to gravity what? Decreases, and if you go down, acceleration due to gravity what? Decreases. Now I am going to teach another topic of the same chapter, and the topic is gravitational field. Okay, the topic is what? Gravitational field. The space surrounding a planet. Okay, the space surrounding a planet. Suppose this is a planet, this is a Earth. Okay, the space surrounding a planet, the space around the planet. Okay, the space around the planet in which its gravitational force of attraction can be experienced. Okay, in which its gravitational force of attraction can be experienced. Suppose up to here. Okay, this is the space around this planet. Okay, up to where gravitational force can be experienced. Okay, up to where gravitational force of attraction can be experienced is called gravitational field. Okay, the space surrounding a planet in which its gravitational force of attraction can be experienced is called gravitational field. Field means space. Field means what? It is given by gravitational field intensity I is equal to force experienced divided by mass. Okay, gravitational field intensity I is equal to force experienced by this planet divided by mass of the object is equal to F by m. If the body of mass m is kept at the distance d from the center. If the body of mass m is kept at the distance d from the center of the Earth of mass m and radius r, then force experienced, okay, then force experienced by the mass of the planet is given by the formula F is equal to gmm by d square. Okay, F is equal to what? Gmm by capital M small m by d square. To calculate the gravitational field intensity, we have to take a unit mass, so m is equal to 1 kg. Okay, gravitational field intensity is measured only for 1 kg mass, not for 2 kg, 3 kg mass. Okay, so gravitational field intensity I is equal to gm by d square. Okay, if you put the value of m 1 kg, then after capital M into small m, that is equal to what? Capital M into 1 m, so gm by d square. If the body is at the surface, of the earth, d is equal to r. Okay, distance is equal to what? Radius. Okay, then I is equal to g capital M by r square. Instead of d square, we can put the value, okay, r square. I is equal to gm by r square. Okay, this is numerically equal to the acceleration due to gravity. The SI unit of gravitational field intensity is what? Newton per kg. SI unit of gravitational field intensity is what? Newton per kg. Write down one numerical problem. The earth has the mass of 5.975 into 10 to the power 24 kg and the radius of the earth is 6,370 km. Find the gravitational field intensity at a distance of 500 km above the surface of earth. Earth has the mass 5.975 into 10 to the power 24 kg. Suppose this is earth and its mass is what? 5.975 into 10 to the power 24 kg. And radius of the earth is 6370. This radius of the earth is what? 6370. Then we have to calculate the gravitational field intensity at a distance of 500 km. Okay, we have to calculate the gravitational field intensity at a distance of 500 km. It means this distance is what? 500 km above the surface of earth. Solution. Here mass of the earth capital M is equal to 5.975 into 10 to the power 24 kg. This is the mass of earth. And radius of the earth r is equal to 6370 km. We have to convert kilometer into meter. And height is equal to 500 km. Height was 500 km. We have to convert kilometer into meter. So 500 into what? 10 to the power 23 meter. And radius r is equal to total radius r plus h, that is 6370 plus 500 into 10 to the power 3 meter. Then we have formula to calculate gravitational field intensity, that is I is equal to g capital M by r square is equal to, what is the value of capital G? 6.67 into 10 to the power minus what? 11 into mass of earth 5.975 into 10 to the power what? 24 kg. And r is equal to what? 6.87 into 10 to the power 6 square. Okay, 6.87 into 10 to the power 6 square whole square is equal to total its gravitational field intensity is equal to what? 8.544 Newton per kg. Newton per kg is the unit of gravitational field intensity. Now write down one homework. Mass of planet is 6 into 10 to the power 20 kg and its radius is 3 into 10 to the power 5 meter. Then calculate the gravitational field intensity of that planet. What will be the weight of a person whose weight is 50 kg? Okay, whose mass is 50 kg? Whose mass